This is my first attempt at building a proper lab power supply. Not just something that works, but something I'd actually trust on my desk. Because most of the time I'm either using phone chargers, random adapters, and AA batteries and hoping I don't destroy my components. And professional lab bench power supplies are kind of expensive. So I want a clean, adjustable, and reliable DIY power supply. Before we start, if you enjoy these kind of projects, please consider subscribing. Most people watching aren't subscribed and it really helps the channel. Now for the components. Starting with a 300 watt buck converter as the main power supply, an LM2596 regulator for auxiliary power to power the digital voltmeter and the cooling fan, 2 precision potentiometers for control, banana terminals and DC input jacks, alligator with banana plugs wires, threaded inserts, a big toggle switch, and I use a 12 volt 6 amps external power supply, but you can add another more powerful up to 46 volts. I started by replicating all the components in Fusion and arranging them to fit everything properly. The goal was to make the layout clean and intentional, not just functional, and also, very important, modular. I also added mounting points for threaded inserts, so I could open the case easily and upgrade it later. Once the design was ready, I printed everything in PLA. After printing, I installed the threaded inserts, both in the main structure and the cooling fan. This is where things get more tricky. The core of the system is a 300 watt buck converter. That's what handles the main voltage adjustment. But there is an important modification here. The original model comes with small trimmer potentiometers, which are not very user-friendly. So I replaced both inputs with external precision potentiometers. This allows much finer control over voltage and current and makes the interface more usable. Also very important, the pinout matters. Each potentiometer has 3 pins: voltage, ground, and signal. So you need to match those correctly with the original input pads on the model. For auxiliary systems, I use an LM2596 regulator to power the display and the cooling fan. I started by installing the DC input in the main switch. Then I mounted the main buck converter to its base. For the LM2596, I soldered the wires horizontally, so it could sit flat and be screwed into place. After that, I fixed all the modules into the main structure. Before connecting the outputs, there is a critical step. I powered the system, adjusted the LM2596 output to 12 volts. This is extremely important. If you skip this, you can easily damage the fan or the display. Once everything was calibrated, I moved to the front panel connections: the banana terminals, switches, display, and DC jack output. Quick note here: the 2.1mm DC jack used in the video is slightly different from the one in the final design. In the component list, I include 2 identical ones to make things easier to replicate. After finishing all the connections, I will leave the full diagram in the description. I did a final test and then closed everything up. At the end, I added a potentiometer knob. I also used a small adapter wire to make it fit properly. And that's the final result, a simple, adjustable, and reliable lab power supply. But now, I have a tool I can actually use in the future projects. If you like the video, consider subscribing and supporting the channel. It really helps me keep building and sharing projects like this.